Today, I'm going to demonstrate Ladybug's unattended operation feature. This is option UOP, which is available on any Ladybug LB5900 series power sensor. The option allows you to make unattended measurements with only power applied to the sensor. These measurements are stored internally in the sensor. We're going to use a Berkeley Nucleonics Model 865 source for this demonstration. Now I'm going to show you how to make basic unattended measurements using the Ladybug LB5944L power sensor and its unattended operation feature. This sensor covers 9 kilohertz to 44 gigahertz, which is a pretty broad frequency range, but you can make this measurement with any LB5900 series product that has option UOP on it. We're going to make this measurement at 40 gigahertz because the sensor has the capability and the source we're using has the capability. We're using a Berkeley Nucleonics Model 865 power source. It's a very nice signal generator. The front panel on the device is easy to use, and it also has a nice GUI, which I've got on the screen right now, and I've been using. They look similar, and so it's really easy to go back and forth between them. This source has a lot of flexibility. I'm going to go ahead and set it to 40 gigahertz. So we can make our measurement at that frequency. I'm going to turn the power on. I'm going to jump over to the sensor and I'm going to change that to 40 gigahertz. But before I do that, I want you to notice that where the power level is, it's right at 40. It's 40.5 dBm. Now I'm going to change the frequency to 40 gigahertz. So I've just changed the calibration for the sensor from 1 gigahertz to 40 gigahertz, and we got a very, very small change in power level. Now, if you've used a lot of power sensors, you know that means the sensor is very, very flat across frequency. So if you're making frequency hopping measurements or anything where you can't change the frequency and it might change a little bit on you, this is really an excellent sensor to use for that. So we're all set there. I'm going to change my averages to 5 just so we can get a quicker settling, even though it's not really necessary, but up at minus 20 dBm where we're going to be working, we really don't need a lot of averages. So if I was down at minus 50 or 60, I would increase that so we would mitigate the noise a little bit. Now I'm going to jump back over to the source here, and I'm going to go to the sweep. And the reason I'm sweeping is because we're going to be using an unattended operation, and I'm going to store the measurements, and I just want to show you something. So I'm going to set up a power sweep, store it in unattended mode so you can see how it works. So I'm going to be sweeping from minus 20 dBm to plus 20 dBm. I've got it set with 100 data points, so it's going to be a pretty smooth line unless you zoom in on it. And then it's got a dwell time of 200 milliseconds per point. It's got automatic leveling control, which the sensor has automatic leveling on the output, which is a nice feature. So now I'm going to turn on the sweep, and you'll see it show up on the power sensor's strip chart, sweeping from minus 20 to plus 10. Now I'll jump up and start in on the unattended operation. Now we're using the PMA12 power meter software to control the sensor. We could do this programmatically, but it's just easier for a demonstration unless it's specifically about programmatic control to use the software. So I'm going to set the sensor to UOP, putting it in that mode, and it's really the software that's in the mode. It's just preparing to send commands for unattended operation. It's all ready now. First thing I'm going to do is going to go into the Manage UOP, and I'm going to clear the memory. Now it's not really necessary because if you make multiple measurement sets, for example, if you've got it set up to make remote measurements and you depower it and repower it and depower it and repower it multiple times, it'll just store those as separate blocks of data, and each measurement is time stamped with a very accurate time base which is in the sensor, and it is backed up with a supercap, so it's got several days worth of storage before you lose the clock, and all the memory is non-volatile, so it'll be there for a year or longer. So now I'm clearing the memory in the sensor. I get the warning that I'm erasing it. So when we stop the measurements, it will be only one data set in the sensor. So now we're ready. So now I go to the Start UOP drop down, and you'll see there's 2 points here: Save Data and Do Not Save Data. I'm going to start the unattended operation and saving the data to memory, and while that's occurring, I'm going to tell you why we have the other choice there. So now the UOP is in progress, which means the sensor storing the measurements. The reason we have do not store measurements is we have a calibrated analog output capability on the sensor. So we call it recorder out, and it's a fully calibrated output that you can scale to whatever your needs might be, 0 to 1 volt. And that output can be run with no computer attached and no user intervention. Once it's set up, it's just like UOP in that you don't need to do anything. You just apply power and it starts working. And so we have that set up so that when you go in here, you don't have to continually write to the memory and use the memory unnecessarily. So now I'm going to halt the UOP. And we're then going to collect that data back. And I'd like to point out that you can store 50 million measurements in the sensor, and these measurements are currently being made at 1 millisecond apart. That's the default rate unless it's changed. And I'm now going to retrieve that data that we just made. And so here it is, and I'm going to tell it to bring back in the maximum amount of data, which is everything. And if we had many measurements in there, we could pick which set we wanted, and that's the purpose of that previous screen. So here is the data that came back in, and you see there's an index, a date, and a time, and a power level. And now I can store this and open it in Excel. I can do whatever I want with it. But what I'm going to do here is I'm going to send it to a new strip chart. And this strip chart will be just like the one we were using before we had the measurement storage turned on. And so here is what was stored in the unattended mode. I can zoom in on that and see each little spot there is a data point, and it'll do this for days and days and days. Store it, and you just collect it back whenever you want it. Very useful for a lot of operations, field operations, where you just want to monitor the power and bring it back in and collect it. I hope you found this video useful, and thanks for watching.